And I'll start by sharing my screen. Right. Okay, so let's make a new scene. And I want to go over something that is quite Unity specific, which is called prefabs. So let's try to model using Unity primitives some type of an object. So I'm gonna start with, let's start with a capsule. So place it somewhere, oops, in the origin. So I'm gonna sort of rotate it, something like that. And you're gonna see what I'm going for. I'm gonna call this body, oops. And then duplicate once, sort of move it a bit to the side, scale it all out down. Go something like top view. And this time I'm going to scale it something like this. Let's call this a leg. And I'm going to make sort of like 4 of them. Whee. Okay, I'm getting somewhere. And the last thing I'm going to make is a sphere.
Is this supposed to be like an insect or something?
I'm going for a dog, but yeah.
Oh, okay.
Could be an insect, why not? Um, all right, so this is going to be, oops. This is going to be the head. Right, so I want to sort of compose this into some type of an object. Okay, so I'm going to make an empty game object. Again, I'm going to place it in the origin, and I'm going to name this a dog. So then I'm going to get all these primitives that I made and make them children of the dog, but the legs I'm going to make children of the body, and the head also a child of the body. Right, so I have my dog. There we go. Hey, my dog is missing a tail. Let's make a tail for the dog. You can't have a dog without a tail, no? Okay, so I've made some type of a object that looks very funny, modeled from primitives. So now what I want to do, I want to be able to have multiple instances of this particular object, right? So I'm going to make a new folder, call this prefabs. Okay, so I want to show you one item that is specific to Unity. So whenever we have an object that we want to use many times, we can store it in our assets by click and dragging to the assets, and you see we get a shortcut like icon. And this is made now into something that's called a prefab. And what prefabs are are nothing more than collections of objects that you decide they are worth to promote to a reusable item, right? So now I can just drag a few of them in my scene, and well, you see what it does. I have perfect copies of the object. Now, what's interesting, if I now go and open the prefab, I get this sort of editor. And let's do a bit of customization. So I might go into materials. Let's call this fur, and our dog can be, let's call it sort of like brownish color. So what's interesting that whenever you update a prefab, so I finished sort of editing my prefab, I can go and close it, and you see, whoa, all my prefabs have been updated. And what's interesting, even though I've edited the master prefab, I can still go into this guy and change my specific color, right? So I could still do something else, right? I could still change them. Okay, so that's quite good. Now, maybe let's put this also into a folder called materials. So drop it in there. So that's all good. Now I'm gonna delete these dog copies for now. And let's go back to actual writing code. So I'm gonna make a new folder called scripts. So I want to start a new C# script, and let's call this code composition. Right. So what I want to do is first go over some of the basic ways of going through code. Okay. Now I need a bit of data to actually use. So let's go first. Let's make an array. Let's make an integer array, numbers, and let's just drop in there a few numbers. Okay, so I have in here 6 numbers going from 0 to 5. Okay, so the first thing when you have code, you know that it's executed from top to bottom, line by line. But what happens if you have a requirement to sort of after you have executed a line, you want to go and execute again the same instruction, right? To do that, we have loops. So the loop allows you to go from one line of code instead of going down to jump back up in the stack of the code. And the first type of loop is the for loop. Okay, and the way this one works, and you've seen it already, you have a counter that counter start, then you have counter end. So when does this jump back and forth ends, and counter increase or counter step is what is going to change from each iteration of the code, right? And you saw quite nicely that we write it like this: for we declare a counter, we have to declare what is start value, then we have to declare what is the counter end value. So for us, I'm going to go a numbers array, so I might as well use the length of that array as a variable. And then I have to say what is the step size. So for me, counter is going to step by 1. Right. Now, this should allow me to go nicely over the array, so I'm not going to do anything interesting with this. Well, let's do something. We keep printing to the console the same values and values. So for example, let's say I want to add all the numbers that are in this array. So what I can do, locally make myself a variable called sum value, and what I'm going to do, I'm going to say sum value is equal to sum value plus numbers, and I'm going to get the counter variable, right? So this allows me to sort of go, okay, what's the instruction? First instruction is start at 0, check if 0 is smaller than the length of the array. So 0 is smaller than 6, yes, go ahead. Then if that is true, jumps into the instruction itself. So the instruction is that the sum value, which was 0, we're adding to that value the current number from the array. So it's going to be 0 plus 0, not much changes. So maybe here let's put 99. And because
You're muted, Octavian.
okay, sorry, someone muted me. Is my voice that annoying? Okay, now I guess you can hear me, no?
Yes,
Yeah.
Okay, so I was saying that the condition was not met for the counter. So it jumps and it increases and says, okay, now counter is equal to counter plus 1, which was 0 plus 1, so it's 1. It goes in and check, is 1 smaller than the length, then 6, no. Executes the next line, which is the sum value, which now is 99. Adds the next value because the counter increased, so it gets this value, and so on. So this loop allows me to execute this sequence from 15 to 17 up to a number of times until the condition is met. Okay. Now, what's interesting that well, now I can go and print that value.
Octavian, hi.
Yeah.
The numbers you wrote, what does it do exactly? Usually we would write like +1, right?
For?
Some value equals some value plus numbers. What does numbers mean here?
Because numbers is my array, right?
Oh.
In my array, I have a bunch of numbers, right?
Yeah.
So from the array, and if you remember the way we retrieve data from the array, we have to say at what index we want to get that data from, right?
Yeah.
So because I'm using the counter, I'm pretty much going and getting data at index 0, data at index 1, at index 2, at index 3, 4, and 5.
Yeah, so the counter is like the I you used to use, right?
Yeah, but because I was describing here how it's actually written, I actually use counter. But you're right. The version that you've seen so long was with integer I equals 0. And that's more like a notational thing, right? Most people in for loops use the I variable.
Okay, thanks.
Now, that should work. Let's see if it works. Yeah, I get no specific. It definitely works. And if I play this, I should see my... Oh, wait a second. I haven't actually attached this script. Well, let's attach it to the dog. Why not? Okay, so I see this printed, 114. Fine, it works. Now, there is a short version of the for loop, which doesn't use a counter. So how does this one work? So the shorthand for loop goes something like this for each, and you say the variable, and for me it's not going to be an item, it's going to be let's call it current number, or actually let's just call it number in numbers. Okay, what I'm going to do, actually let's do current number, because then it's a bit more clear. So what I'm going to do, in here as well. I'm going to say some value shorthand plus equals, plus equals current number. So these two for loops do exactly the same thing. The difference that in the shorthand for loop, we don't use a variable. So essentially what we're saying, for each item in numbers, and I'm saying current number for each, and that's why maybe a better notation would have been for each number in numbers, add that number to the sum value, right? And I find this a bit more intuitive, right? Because we know that we're storing numbers, and what we're saying for each number in that array, add it to a sum value, okay? And let's see that that works. And here we should change that to that, right? And let's see it in action. Okay, that works. So I should see twice the same number printed, right? And there we go, twice printed. And the shorthand for loop is quite useful whenever you know that you want to go over all the items that you have in the array, right? Okay, now another type of loop is the while loop. And the while loop is a bit different because it starts something like this. Ask if condition is met. If not, execute loop. Now, I want you to be very careful when you use a while loop, because the while loop has a bit of a problem. It can go infinitely. So if you do not set a condition that can be met within the code, the loop will continue infinitely, right? The for loop, no matter what, it ends at some point, because you're just saying either for each item that you have in some data structure, or even if you use a counter, that counter for sure gets increased by the nature of how the loop is set up. You always step in, right? Now, the while loop is a bit different because it sort of makes us responsible for making sure that loop is at some point ended, right? So how do we write it? Well, while, and in here you have to set up a condition. So I'm going to actually declare again a counter, and I'm going to set it to 0. So I'm going to make it similar to this one, but I want you to see how it works. So I'm going to say the same thing, while counter is smaller than numbers length. Okay. Someone joining? Oh, okay. Someone was joining. Okay, great. So where were we? Okay, so in here, while the counter is smaller than the length of the array, what we're going to do, well, similarly, we're going to do a while sum, and again set it to 0. And in here, what we're going to do, the while sum plus equals numbers counter. Okay, now this is what I was telling you. You have to make sure that this condition is met. Because, for example, if I run this now, it will go infinitely and will keep adding the first value, right? The 99. I will go 0 plus 99 equals 99, the 99 plus 99, 188, and so on and so forth until infinity. And I have to make sure this condition at some point is met, and it's very easy to make that condition. I'm just going to increase the value of the counter, okay? And after I finish my loop, I can again go and check that it actually is working, and instead of sum value, I'm going to show the while sum, okay? Good. Let's see if that works. Oh no, a local parameter name. Oh. What? Okay, let's see if this works. I think he gets confused because we have the counter declared in other parts. So he's okay, it does work now. So we were using the variable in another place. Okay, so let's see if we get prints 4 times. Yeah, there we go, 3 of them, perfect. Right, so that is looping. And let's make ourselves a bit of, oops. Now, the next part I want to show you are conditionals. So what if we want, based on some information in the code, to take different decisions, right? So for now, our code always is executed top to bottom, and we have this ability to jump from one line back to another line. But what if we want to have to sort of ask questions? So let's see the most useful one, if conditional. So again, maybe for this, let's declare some booleans. Let's set this one to true. Set this one also to true. And let's make another one. And this one will set it to false. If I could spell right. All right. So, and my spelling for condition is horrible. Condition 3. Okay.
Yeah, and condition 1.
Yeah. There we go. Okay, so if conditional, the way this one works, you're going to ask if, and inside of this you can use a boolean, you can also check some number, but for now let's use our condition. So we're going to ask if this one is true. Then what do we do? Well, we have if that condition is met, we execute some code. But we can also do the opposite. So for example, if the condition is not met, we execute another piece of code. Right? So this part, the else part, is optional. You don't have to always have it. So the else condition, you don't have to have it always when you write the code. Now, this is very useful if you want to ask one condition, but what if we have multiple conditions that we want to ask, right? So we have some simple way of doing this. The first one is called concatenation, or asking multiple questions. And it looks very similar, and you still use the if, and you say, hey, if condition 1 is true. And the way you concatenate, you add the and sign, right? And you're seeing something quite interesting. You see that I'm using double equals. whenever in code you see doubling up of something, it's a sign that within the code, you're not setting out a value, you're asking something about a value, right? So for example, when here we say word counter equals to 0, we're setting that value, right? Whereas whenever I'm using a double equal sign, I'm almost asking what is that value, right? Okay, so if condition 1 is true and condition 2 is true, then we execute some code, right? Now, in order for this code to be executed, both conditions have to be true, either true or false, but either both are true or either both of them are false. So it can't be that one is true and the other one is false. They both have to be the same, right? So that's concatenation. There is another one which is called the OR. So in this case, at least one of the conditions is met, right? And it looks very, very similar. The difference is that we use these parallel lines, right? And then we go condition 2. So as long as either one of them is met, we execute the code, right? Very similar. Okay, great. So I think with this, you will be able to sort of go over most of the things you need to do with code. You will be able to loop, you're going to be able to ask questions. And you can ask a simple question, or you can ask a question that takes in a few conditions, right? Which can be either all of them true or all of them false, or either one true or false. Now, you can concatenate or ask or for as many as you need. So for example, I can also ask if condition 3 is met. And for example, for us, we know that this is not met because we set it to false. So you can ask more than one condition, right? And same with concatenate with the OR question. Right. I'm going to end here. This part is quite dry. Now I want to show you, and this is where we're going to use our prefab. How we use code to actually drive something in Unity. So I'm gonna drive this specific dog, okay? Okay, so to do that, I'm going to do something quite different. So far, I remember we were always creating here a new C# script. Well, we're gonna do it now from our code editor. So I'm going to do a new file. This one is code untitled 1, not very useful. But what I'm going to do, I'm going to save it. And for this, it's so nicely in here. Let's call this dog, and I don't want text. I want C#. So it's dog C#. Okay, so we now have the most empty, lonely code ever possible with one line of code. First thing, let's use libraries. So I'm actually going to use from the system, so very similar to this part. So I'm going to use system collections. Actually, I'm just going to copy it because I'm quite lazy to write. So I'm going to use the same libraries as the Unity code. That's good. Now, I do have access to the libraries, and I can see they are highlighted nicely for me that this works. Now, the next difference you see in the normal code when it gets created from Unity, what we automatically get a class that extends mono behavior, right? And I was telling you that the code, whenever you see this dot, means that it's implementing more functionality within the environment where you're working. So for us, mono behavior is the environment of Unity, and essentially our code extends the functionality of Unity. Now, I want to make something that is my own, that has nothing to do with Unity, right? And let's do this. We're going to use something called namespaces. So namespaces are sort of a, let's call them mini libraries in a way, but yeah, let's call it, so it's think of it like this. So if you go to a library, you have a bunch of books, and a namespace is literally just one of the books, right? And you can use the content of that book to do something, right? So for example, if it's a cooking book, I could have an Italian cooking book, right? And it will teach me how to do pasta and pizza, for example. So I'm gonna make my own namespace. And in here, the namespace, well, let's make it a DRL, why not? Okay, so that's great. And within the namespace, I am going to do my first thing. So the namespace allows me to build in their classes, similarly to the classes that Unity is having. But I'm going to now do something quite different. So I'm going to make a public class, and this class I'm going to name it a dog. And this class will not extend anything. It's not going to make more functionality for other parts of the code. It's going to just be for Scratch. So it's a new code that it's independent of Unity, right? It will work the same even if I'm outside of Unity. Now the class still follows the same things. You'll have variables. There's going to be something different that you haven't seen, which is called a constructor. And the last thing are the class behaviors or functions. And let's see this. So I'm going to make a class object or class category. Now, if it's a dog, for sure is going to have a name. Now, I think it's going to have a height. What else? What dog will have? Well, I think it's going to also have a type, right? Or a breed, I guess. I would say for now, oh yeah, we can also do, because we have access to Unity, we can use the color variable. It's going to have a fur color, right? Okay, great. So now that I've set up what are the variables that this specific object might have, I have to actually describe how this object gets created, right? And for this, you have to make a constructor, and the constructor works something like this. You say that, hey, I want to make a new dog, and you pass a few variables. So for me, the passing variables are the name variable. I'm passing in the height variable. I will pass in the breed, and the last thing I need is the Okay. Okay, so now you're seeing something. I have local variables that are sort of named similarly to the global variables, just they have an underscore. And this is generally what most people who write code use as notation to say the local variable is initiated or is being set outside of the code, right? So quite straightforward. My name will be equal to underscore name. Oops, not the breed. And for color, right? So essentially what I'm doing in the constructor, I'm asking whoever constructs a new dog, right, to give the name, the height, the breed, and the color. Great. Now, what would be some of the functions? Well, as you would expect, a dog would probably run, and I would have to sort of describe the functionality of actual running. Right, so I will actually have to run it. What other behaviors the dog might have? Right, he will probably want to eat from time to time. And similarly, I might need to so on and so forth. And I might have more functionality. I might even have some other functionality that's private, right? Like it's not executed from outside, but for now, let's do that. Okay, good. Let's go to Unity. And I am going to do something in here. So I have my dog, it's working. I'm going to remove the script and I'm going to make an empty game object. And this one, let's call this a dog handler. So someone who handles dogs. Okay. Now, what I'm going to do, I'm going to make a new C# script. So in here, this one is a Unity script, and I'm calling it the dog handler, and I'm going to attach it to the dog handler itself. Okay. Right. So what I want to do is that I want the dog handler to create a few dogs, right? Right. So to actually have access to the dog class, I need access to the AADRL namespace, to the library. So sort of, in order to become a dog handler, someone has to give you the instructions how dogs operate, meaning what their behaviors are, and how you create a new one, right? Now, very similarly, I'm going to actually use AADRL, okay? And this is quite crucial because it allows me to get access to the dog class, okay? Now, I can have in my namespace more than one class, so I could have also, I know, let's say, I can make a class for tutors, why not? Very similarly, so what the variables might be, something like this. So Okay, so I can have more than one class within my namespace.
Probably sort of on.
Yeah, thank you. Right, so I can have more than one. And now let's see how this works. I want my dog handler to have access to that. So what I want to do, maybe in the start, let's create a few dogs. So in variables, I will store my dogs. So I'm going to have a few dogs. I don't know. I guess I have a dog French Terrier. What else? I have an English Bulldog. I'm not a big I don't really know many dogs. I guess something like that. Right. So I might make a few. Let's make 3 of them. So how will I do that? I will just need to say that the French Terrier is going to be a new dog. And what do dogs need? If we remember, they need a name, a height, a breed, and a color. Okay. So in here, I'm going to give the name. So let's call Louise. Is our French Terrier. Name height 1.0 float. Breed, well, the breed we know it's a French Terrier. And then I need a color. And for this, I'm going to make a new color. And whenever we make a new color, remember we have to give the RGB values. I don't know, let's make a blue dog. So 0 in red, 0 in green, and 1 in blue. Okay, so that will initialize a new French Terrier. I'm just gonna check that the code is actually working, that I don't get errors. And there we go, no errors. Fantastic. Now I'm gonna do the same for our English Bulldog. This one is gonna be John, I guess. And let's make this one a green dog. Okay, and the last one, let's make our German dog. This one we're gonna call Hans or something like that. And this one is gonna be red. Great. Okay, so we've created our dogs, but that's just data, right? It doesn't actually physically exist within Unity, right? I just have a bunch of dogs, right? So what I'm going to do I am going to make also a reference to our prefab, right? And this one I'm going to make public. Okay, so this is going to be a reference to our dog prefab. Save the script. So what we have to do now, let's wait for a second. I'm going to delete the dog that I have in my scene. With the dog handler, you see now we have an entry for the dog prefab. I need to go in the prefab and drag it on top of here, and now I've linked my prefab to the variable dog prefab. And what we're going to do, so we've initiated our dogs. We want to actually instantiate or create a new prefab, okay? And let's see how that works. Okay, so it's quite straightforward. You have to give the prefab, you have to give the location, and you have to give the rotation, okay? All right, so we're gonna do just that. And what we want to instantiate, a dog prefab. Then we have to give it a position, right? And let's space our dogs so we don't put them on top of each other. So I'm gonna make a new vector 3, and you have to sort of give the values. And I'm gonna space them in the x-axis, for example. So the first one is going to be in the origin. Okay, so that's the position, and then you have to specify how it's rotated. I'm not gonna rotate them. I'm going to use default rotation, which is called the quaternion identity. Now, later on, we're going to talk quite a bit about quaternions. In computer world, rotation is described through these items that are called quaternions, which they're not very intuitive to explain. It's not really easy to explain them, but they're quite intuitive to use. And we'll get there. But for now, trust me that this is just saying that it's not rotated. Let's see if this works. And obviously it doesn't. Oh, I gave 4 arguments. Vector 3. That's weird. 1. IDNT. I'm an IDNT. Okay, 0.0f. And I probably misspelled quaternion. I didn't, it's just identity is with lowercase. So quaternion identity. I think I misspelled quaternion, am I right?
Yeah, you missed an A.
Spelled it.
God damn it. Okay, let's see if that works. Yay. All right, so there we get the dog clone. Ha 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 ha. Okay, let's do something. So let's make our dog clone a French Terrier. And for this, I am actually going to use yeah, let's call this Yeah, dog instance 1. So what we're going to do, we're going to say the dog instance 1 dot name will be equal to French Terrier dot name. And I have a bit of a problem because I have not made the variables yet visible. So that's easy to do. You just need to say they're all public. And for color, I think I'm going to make it private. Well, actually, yeah, let's make it private. So it shouldn't be changed from outside the code. Okay, so now dog1, the instance, the name will become French Terrier's name, and let's see if that works. So instead of clone, I should get that is named a French Terrier. So I get Luis. Nice. So it's no longer a clone, it's actually Luis. Then I have to do a few things to change it, right? So the variable that we're passing after is the height. So I can do dog instance 1 dot scale. And actually it's not the scale because we need to get the transform, right? The transform holds the scale. Okay, it will be equal to French Terrier scale. And let's do something. I know the German dogs are actually quite big, so we're gonna make this twice. And I know the English bulldogs are quite small, so I'm gonna make them a bit smaller. Okay, so I'm setting out the scale. And I actually need to set the color as well, right? But let's see that it works. So, ooh. And no definition for scale. Oh, height. Yes, so here instead of scale, actually height. Should be able to get the scale directly like this. My spelling is horrible. Let's do a bit different. So I'm gonna get component okay, that should work. So from the dog instance, I'm getting the transform, and from the transform, I'm getting the scale. Is it uppercase? This is where Visual Studio Community is much better. Come on. Ah, local scale, god damn it. Okay, so it's not scale, it's local scale. Okay, so local scale will be set to the French Terrier height. still? Ah, okay. So we actually have to set it as a vector. And we're gonna pass these values 3 times. So we want to scale in all directions the same. So let's see. Yay, that worked. Right. Now, I kind of want to do the same thing for my English Bulldog, but here dog instance 2, I'm going to make this guy, and let's move him maybe 3 units on the X. And instead of the French Terrier, I'm gonna use the English Bulldog. And let's do the same here. So this should be dog instance 2. Right, so I have a dog instance 2. I'm making a new dog prefab at that position, and the name gets the English Bulldog name, and the scale it gets it from that one as well. And let's do the same for the German dog. And this one we will move it at 6 units. And this is 3. And in here is the German dog. Alright, so now I have my 4 dogs. There is one thing I didn't do, is actually the color, right? But let's see that this works. I should be getting 3 dogs with their individual names, and there we go. Ta-da! Works very nice. Luis, John, and Hans. Okay, so that's amazing. I'm now using code to actually do something in Unity. Remember, I could even write the behaviors, how these dogs move, but we might do it in a later session. Let's also use the color. So for that, dog instance 1, the component we want is the renderer, right? So if I go to my prefabs dog, but actually, yeah, so for the dog, the way it's set up, let's do something to make it a bit more easy. Just gonna make everything part of the dog, even the body. So now all of these are children of my game object, right? So what we need to do is have a for loop, and we're going to use the for each loop, and the thing we're going to do is use a local game object child in dog instance 1 right. So we want to get all the components, the body, the tail, this one. Let's see that I spelled it right. And I didn't. But I don't want get child, I want all of them. I want I can get the transform. That's easier. Yeah. Yeah, let's use the transform. It's actually easier. Okay, so let's do it like this. Instead of so in here, dog instance 1 transform. Okay, so we're getting all the transforms. Okay, then child game object dot get component of type mesh renderer. And from here, I want the material, and from the material I want the color, and this will be, after many things, French Terrier that for color. I think that's what we named it, right? For color. Okay, so that should work. Let's see if it works. No. Oh, okay, so here this is capital game object. Okay, Duck4 is inaccessible. Oh, because we made it private. Let's make it public. Okay, color for, let's see, and ta-da, no more errors. Let's do this for the other breeds, and this is 2. And this is the German dog. Great, so I should have now 3 dogs with their own names and own colors. Very simple piece of code. Ta-da! It worked! We have our dogs with their own color. Amazing! Okay, this is not the most advanced piece of code, but you get an idea of how to use classes, and more important, how to use namespaces. Okay? Right. Well, let's leave it play and let the code visible. Maybe someone wants to grab it. Any questions about what I showed you today? I guess after your submission yesterday, the last thing you want to do is more things to think about. I will upload the file from today into the files folder if you want to go over the code. And I will leave you with a bit of homework if you want to do it, obviously. So your challenge will be make the make them walk, right? So we do have them now in Unity, but we should see them walking somehow. And I think that is a very interesting challenge, because you'll need to think how you will write a function, which I sort of already did for you. But you have to think how to execute the game logic for the function, right? Now, there is a bit of thing that I need to show you, because now the dog class is fairly abstract, but we do need to somehow inherit the actual game object, right? So in here, well, Unity game object instance is quite long, but I'm going to name it dog game object, and this is a game object type. And we need small functions for this. And this one is going to inherit the game object itself. So how does that work? In here, you're going to say dog game object is equal to the value that we're passing. And we need to go into our dog handler whenever we make a dog. After we instantiate, the best thing to do at the end, after we set the color and everything, we need to say that the French Terrier set, how did we call the function? Game object instance. And in here, we're going to say that the French Terrier is dog instance 1. And we sort of have to do this for all of them. And here the English Bulldog is that. Okay, so this allows me to change the prefab within the dog class. Okay, so now if I want to move my Unity instance of the dog, I can move it from here, right? Because I now have a reference to that. So dog game object. I would do something in here, right? And this is where I would execute logic for the run. Right, so let's clear this. I should have done that not while running the game. Okay, no errors. Great. Okay, let's stop there. I think it's quite a bit for today. If you can try to do this homework, I really appreciate it. If not, that's fine. And I'll see you guys next week. Okay? Enjoy the weekend, and well done on your first presentation. Okay?
Thank you.
Thank you.
Thank you. Bye bye.
Okay, guys. Ciao, ciao.
Thank you. Bye bye.